Hey there everyone, welcome back to my channel. In this video we're going to be using or learning how to use Kafka with Node and Golang, so stick around. Okay, so I read a few comments in my previous videos that my font isn't big enough. This time I made sure I zoomed it in so you guys have all the clarity you need. So what are we doing in this video? So we're going to be trying to leverage this, I don't want to call it a queue service because it's not really a queue. It's called Apache Kafka, and it just allows you to send messages into this queue, and then other services can consume off this queue and just process them. So that's a very watered down explanation of what Kafka does. But one thing interesting between a queue is, so when you think about queue, you think of the message goes in and first in, first out. So as soon as it's popped off the queue, no one else can process it. But due to Kafka's the way it's set up, it has this concept of consumer groups. So you can have different consumer groups, and each of the consumer groups will be guaranteed to get that message. So I saw a good example out there where on YouTube you would upload a video, and there could be many services that need to process a video. You could have a subtitle service, you can have a video processing service. If you had a regular queue, as soon as it is processed, it's not available to other services. But with Kafka, you can assign consumer groups to different, I guess, different services, and then they can consume off this queue and then just do whatever they want with the message. So that's basically what it is. We're going to be leveraging Docker, so make sure you have Docker, make sure you have Node.js, and make sure you have Golang. So I'm going to be showing you like one of the real benefits of like queues and all this microservice related tools is that you can use different pieces of software and they don't have to be the same, different languages, and they don't have to be the same one. So in this case, we're going to use Node and we're going to use Go. So let's set things up first and foremost. So let's create our Docker compose file. So docker compose.yaml, and we have this Docker compose file. We need a Node folder and we need a Golang folder. So now let's go in the Node folder over here and just yarn init-y, and then let's download a few things. So yarn add TypeScript, ts node, and Kafka JS, if I'm not mistaken. That was it. Yeah, so we're going to be using this package over here. There are different packages out there. This one doesn't seem to have a C++ dependency, which is great. I just want to use something straight Node, so this is great, and it has TypeScript support, so that's good. And it seems like it's getting fairly common as well as more downloads happening. Okay, so let's do one thing. Yarn init, yarn tsc -- init, and this will set us up with a tsconfig file over here that will do all our fun stuff. And then we don't need a main over here, we can remove that. And all we need to do is touch and index.ts file. Let's go in here and let's just make sure this works. So console log hello. And then let's go in our package.json. Let's create a scripts key over here, and we're just going to call this start. And it's just going to call ts node. I forget what order it is every time, and index.ts. Okay, so we have that, and we have our ts node. So now let's do yarn start, and hopefully we get an output. And obviously my computer is super slow, so all of this will be super slow. Okay, so we got a hello over here. That means it's processing TypeScript files properly. Let's go out to our Golang folder, and let's go mod init to create, we need to name it too. So in this case, This is going to be interesting. So go mod init is going to be in my GitHub folder, github.com/floydjones1 / node Kafka Go, and it's just going to be in the /go folder as well. Great. So we have our mod file, and now let's create a main.go folder, and inside here let's just create a function main, and I'm just going to fmt.println hello, and I just need to call this package main and save that. And now we should, FMT is not imported unfortunately, thought it would auto import, so import FMT. Cool. Wait, does this have to be a string? God damn it. Okay, so now let's run this go run dot, and that should be able to run our file, and we see our hello over here, which is great. Cool, so we have our basic setup for our Go stuff. We do need to import a package for Go to use Kafka, but we'll get to that soon. Just because if I save it, then it's going to remove the import if it's not used. So okay, so let's focus on our Docker Compose YAML over here. What I'm going to do is I'm going to copy what I had before and paste it over here, and we're going to go through this line by line, right? So we're setting up Zookeeper. So now Zookeeper, Kafka is like think of Kafka as like the, not the brains, but like just the storage sort of component, right? So Kafka has these queues, has these topics, and all that stuff. And Zookeeper is the brains on top of it, where it, what's the word I'm looking for? Where it carries out tasks about rebalancing and creating more partition groups within a topic, creating more topics, all that stuff would go through Zookeeper. So that's what it is for. We definitely need it, or we need there's alternatives out there, but Zookeeper is like the well-known one. So that's set up, and it's set up on port 2181, and it's mounted on these ports over here. This is Zookeeper client port. So this is the port for the client, and this is the normal port. Okay, so now we have our Kafka over here. So this is where we're going to be sending our messages. So we're pulling all these images from Confluent Inc., I guess. And we're using the latest image, and it depends on Zookeeper. So a Kafka won't boot until Zookeeper has been successfully booted. So that's great, because Kafka relies on that. It's going to be mounted on these ports over here. And then these are some environment variables over here: broker ID 1, Kafka Zookeeper connect. So this is just Zookeeper :2181. That's this port over here. And just because this is running in Docker, the way you connect to another service is just, instead of saying something like localhost, you would call them out just by the service name. Advertise listeners, plain text host. All of this is plain text again, more plain text, offset, topic, replication, free factor 1, and auto create topics enable true, just because I'm going to be just creating topics off the bat in my code. So I don't want it to disallow or not allow it. Okay, cool. So we have all of that. And now if we say, first let's do Docker Compose up, right? This might take longer for you because you need to download all the images. I had them all already. So just doing a Docker Compose up, you'll see the Kafka and Zookeeper boot up. And let me split this off into two different ones. And you have to excuse the slowness, because this is what happens when I record and do this stuff too. Okay, cool. We're just watching out for any errors, and now Kafka is booting up. Cool. So the way we can also check for errors is if we open up, if you have Docker Desktop, you can open Docker Desktop over here, and I can see that Zookeeper and Kafka are both green, so that's great. All right, so let's start now the fun stuff. All right, so now let's start off with Node. So Node is pretty simple. First, we got to import the Kafka client. So, oops, I am not on proper language support. Okay, I'm back. So, from Kafka.js, and what I'm gonna pull out is just Kafka over here. That's great because we have IntelliSense. So now let's instantiate our Kafka. So Kafka is equal to new Kafka, and it's going to take in a few options. First, it's going to take the client ID, which is going to be my app. This can be anything, and then brokers. So this is essentially Zookeeper over here. So let's go back to this. Sorry, no, it's Kafka over here. Sorry. So if we go back over here, we say localhost that 29092, and we have that set up. Okay, cool. So let's create a few topics. Since we're using TypeScript, we have the enum, so we can say topics is equal to node prime topic, or I should just say over here prime topic. So prime topic is equal to prime topic over here, and then prime topic update is equal to prime topic update. Cool. So we have that. Now let's create our async function main, and this is where most of our code is going to be. So let's do const consumer is equal to, this is how we're going to consume. So we say Kafka dot, so we have consumer and producer over here. So we're going to instantiate a new consumer, and all we have to pass it is a group ID. So this is the group ID I was talking about. So let's say you have multiple instances of your server running. They would all have the same group ID because they're all doing the same task. So that it makes sure that once a group ID has consumed a topic or consumed a an item off the topic, then it will not be available for other servers, other instances with the same group ID. So I'll just call this group ID is node over here, and then all I have to do is await consumer.connect, right? And then I await consumer.subscribe, and I'm going to subscribe to the topic of topic.prime topic, right? I'm just going to be listening. Golang is going to be sending events on this topic, and Node is going to listen to them. So now I just have to do await consumer.run, and then we pass in an object. So now here there are many things that can get passed in here. So the main one and the most simplest one for almost everyone's use case is we have these different keys. So if we do Control spacebar, you see the different things that are available. So we have auto commit, we have auto commit interval, we have each batch resolve, each message, and all this stuff. The main one that you just have to worry about is each message. So I'll just say each message, and it is a function that gives us a payload. And this payload, if we destruct it and then do Control plus, this isn't working properly actually. It's probably because syntax errors over here, and each message, a void is not assignable. Okay, so let's do this. Payload. Let's see what's wrong. It needs to be a type of promise. So I need to make this async. Let's go over here and say async. Async payload. Each message. Oh, okay. an async function method. Okay, so this is just because of tsconfig over here. So actually, I think it's actually safe if we just delete this for now. And let's see what happens. Let me save this, and that goes away. Cool. So now each message gives us a payload, and the payload is of type each message payload. So let's destructure this over here. If we do control space, we see message, partition, and topic. So what we're going to do is just destructure message, partition, and topic over here. What we're simply going to do is just console log these things for now. So we will console log the partition, because that's a string, topic, that is also a string, and message is not really a string. Message is a Kafka message, so I do want to get a few things off here. So I'll say message, or I can just destructure it over here. I can just destructure it over here. So const is equal to message, and now we can do control space to see all the keys that we have. So the one that I'm interested in is key and value. Is it value? It should be value. Yeah, it should be value. I'm confused why it's any over here while key is a buffer. Anyways, so let's just put this over here as well. So key and value. Pretty sure value is a buffer of type buffer. So I need to do something about that. Just like over here, key is a buffer. So I said gotta say dot to let's see, key dot to, and this is probably because my freaking to string, it's because my IntelliSense is taking too long because there's too many things on here. Okay, so let me save that. And okay, cool. So we have it now consuming it, and as soon as this function exits, it's gonna commit this message. Totally fine. I don't have any problem with that. So now once I consume the message, I also want to send back a message. So what I'm going to do is just create a function here called const dispatch, and then this is going to be a function. So it's going to be a function, and it's going to be an async function. And all I'm going to do here is it's going to, let's see, oh yeah, I made this a closure. So I'm going to instantiate our producer in here as well. So I'll say const producer is equal to Kafka.producer, right? And then I'm just going to await producer.connect. Cool. So now what's this going to do is actually return an async function. And inside this async function, I'm going to await for some random amount of time. So random wait time is equal to math.floor and then math.random. And I'm going any random amount of time between 0 and 10 seconds. And now all I have to do that is await a new promise. And then it's going to resolve in a set timeout, resolve at random wait time. Just to simulate the asynchronous behavior and the benefits of Kafka, I'll just add it in some random await time. And then finally, I'm going to await producer.send. And in here, I am just going to pass it back to our update topic. So I'll say topics dot prime topic update. And then I'm just gonna pass in, so by default it takes in an array of messages, so which is great because you can sort of batch all your messages and send them in. So over here it takes in a key. Key is not necessary, but it is recommended. So math.random, and since key is a string, I need to pass it as a to string over here. And then finally the value and I'll just say success for now. Cool. So we have all that fun stuff. One thing I want to do is value or message. Let's go over here to this type definition. So Kafka message, and then value should be a buffer. Cannot find buffer, you need to install. Oh, okay, let's do that then right now. So are we in Node? No, we aren't. CD node, and then yarn add, what was it complaining about? Types node over here. Cool. So yarn add types node. So that will give us the proper type definitions for this, which is probably why it's complaining. I might need to reload this as well. Let's see. So value is buffer. Cool. Value is a buffer. Nice. So now we can finally do value is value.toString. I don't know why buffer was saying buffer for key over here. Cool. So it's going to give us a string. Let's see. And we want to pass that into, we want to pass the key and value in here. So key string value string. Yeah. So what I'm going to do is I'm just going to pass it back because why not, right? So I'm just going to success from key, this over here, key, and value was this over here, which is our value. Cool. So I'll just do string interpolation for this so I get it nicely embedded. Yeah, and that is about it. Cool. So now all we have to do is run our dispatcher. So dispatcher is equal to dispatch, and probably best to await this because this is an asynchronous function that runs these tasks asynchronously. So we want to make sure there's an actual connection. And then finally in the dispatcher, we're just going to call it over here with our key.toString and our value.toString. Cool. So we don't want to await this because we just want it to run because this has some random interval on it. So we just want it to really commit. So that's all we need to do. Let me save that. That's all we need to do for this. So now let's go to our Golang and let's finish this off actually in part 2 of this series because this video has gone on long enough. If you did enjoy this video so far, please show your support. Drop a like, a comment, let me know what you think. In the next video, I'm going to be completing off the Go portion of this, and we're just going to see the messages getting passed back and forth between Node and Golang. So thank you for watching, and I will see you in the next video. Peace.